This is section 2.4, random variables, and in this video we are going to identify a discrete random variable, define and construct probability mass function, PMF, and a cumulative distribution function, CDF. Also, we'll calculate the mean and variance for discrete random variables. Let's go into the definition of random variables. Well, a random variable assigns a numerical value to each outcome of the sample space. A random variable is discrete if all possible values form a discrete set. If values are arranged in order, there is a gap between each and the next. The set of possible values might be infinite. Let's see some of the examples. Flip a coin. When we flip a coin, we have two possible outcomes. Either we get tails or we get heads. If we identify a number one for tails and 0 for heads, thus our random variable is a real number that is related with one of the outcomes. In a second example, we can roll a die. When we roll a die, we have either 1, 2, 3, 4, 5, and 6. We can have that at the random variable, but we can also create different random variables from this output. In a third example, the number of new COVID-19 cases in a day. So that could be in a particular place, like for example San Angelo. So we can have either 0 cases, desirable, 1, 2, 3. We cannot have 1.5 cases. It's not possible. So that makes this variable discrete. Let's consider the following example. The experiment consists of tossing a coin 5 times and recording the outcome. The sample space is the set that contains all possible outcomes, and one outcome is a combination of tails and heads. The size of the sample space is 2 to the power of 5, and that's equal to 32. Now, suppose that we are interested in the number of heads. So we define the variable x as the number of heads in an outcome. So the range of x, which means the possible values of the variable x, is going to be either 0 heads, 1 head, 2 heads, 3 heads, 4 heads, or 5 heads. Random variable x is a function of the sample space to the real numbers. That is, x is a function of the sample space to the real numbers. In this example, we are counting the number of flows in one each copper wire manufacturer. We found that 48% have no flows, 39% have 1 flow, 12% have 2 flows, and 1% have 3 flows. Let's define x as the number of flows in the randomly select wire. So we have either no flows, 1 flow, 2 flows, 3 flows, and that's all the possibilities. So therefore, the range of x are the possible values that our variable can take. So we have 0, 1, 2, and 3. Now, the probabilities are given by the percentage of flows that we found. So in the no flows case, we have 48%, so the probability is 0.48, 39% in the second case, 12%, and 1%. We can plot these probabilities in a plot. In the horizontal axis, we have our x variable, and in the y, we are plotting the probabilities. So when we have no flows, 0.48. In the case of 1 flow, we have 0.39, and so forth. So we can see that because we have a discrete variable, the probabilities are just dots in our diagram. In the last example, we assign probabilities to the random variable. That's called probability mass function. If x is a discrete random variable with a given range, then the function p of x is equal to the probability that x is equal to one of the variables in the range. That's our probability mass function. The probability of x is equal to the probability of x being equal to one of the variables in the range, or 0 if not. In the general case, we are going to have a set of points that define our random variable. So if this is a probability mass function, it will always happen that the sum of the probabilities for all the variables in the range is equal to 1. Cumulative distribution function. The probability mass function specifies the probability that a random variable is equal to a given value. The cumulative distribution function, or CDF, specifies the probability that a random variable is less than or equal to a given value. Let's consider our previous example. Consider that we want to know the probability of having 2 or less flaws. We have to add the probability of not having any flaw plus the probability of having one flaw plus the probability of having 2 flaws. We can write that in the following way. F of x, now uppercase f, is equal to the probability that x is less than or equal to a given value. We can plot this result in the following way. For each value of x, we add the previous probability. So for 0, we start adding the probability of having no flaws, 0.48. Then when we reach 1, we have to add the probability of having 2 flaws. So we have to add 0.39. That will give us 0.87. We have to keep adding the probability of having 2 flaws and the probability of having 3 flaws. The final value is equal to 1. So our cumulative distribution function starts from 0 and ends at 1. Mean for discrete random variables. Let x be a discrete random variable with probability mass function p of x. Then the mean of x is given by mu of x, which is equal to the sum of xi multiplied by the probability of x being equal to xi. And this sum is over all the elements in the range. This expression can be considered like a weighted average. Now, mu of x is usually referred to or known as either mu, the expected value, p of x, or the expectation. The variance for discrete random variable is defined in a similar way as the sum of the square of the distance of the variables with respect to the mean multiplied by the probability of x being equal to xi. This can also be written as the sum over I of xi squared multiplied by the probability of x being equal to xi minus the mean of the population squared. Now the standard deviation is defined as the square root of the variance.